Have you ever just stopped and looked at the perfect spiral in a seashell, or the wild, intricate patterns on a snowflake and thought, is this all just random? Well, today we're diving into this incredible idea that the universe itself might be a grand design, and its architect, well, maybe the first artist.
For literally thousands of years, thinkers have stared at the unbelievable complexity and harmony in the natural world and asked this very question. Is all this staggering beauty around us just some kind of happy accident? Or could it be part of a deliberate, elegant design?
So, to figure this out, we're not just going to stick to philosophy. Nope. We're going to be detectives. We're going to look for clues in the one language that seems to connect everything, mathematics. And trust me, this is where the evidence for some kind of design gets really, really compelling.
Okay, our first major clue is a super famous mathematical pattern. You've probably heard of it, the Fibonacci sequence. The rule behind it is actually incredibly simple. Each new number you get is just the sum of the two that came right before it.
The whole process is it's beautiful, right? You start with 0 and 1, add them together, you get 1. Then 1 plus 1 is 2, 1 plus 2 is 3, then you get 5, 8, 13, and on it goes forever. The real magic here is that this dead simple code creates a sequence that shows up in the most unexpected places you can imagine.
Just take a look at a sunflower. Really look at the seed head. They're all arranged in these perfect spirals. And if you count the number of spirals twisting one way and then the other, you'll almost always find two back-to-back Fibonacci numbers. It's wild.
But it doesn't stop there, not by a long shot. The exact same thing applies to the scales on a pine cone. The number of spirals that twist up its surface, it follows the same mathematical rule.
We even see it in the way spines are arranged on a cactus. So, a sunflower, a pine cone, a cactus. At this point, you've got to admit, it's getting pretty hard to just call it a coincidence.
So, the big question isn't just what the pattern is. The real mystery is why this one? Why has nature over and over again across totally different species landed on this exact mathematical code for how to grow? And the answer? It's just beautiful.
You see, it turns out this has nothing to do with just looking pretty. It's all about survival. That elegant spiral in a sunflower? That's the absolute most efficient way to pack in the maximum number of seeds. And the way leaves are arranged on a stem, it's all about making sure every single leaf gets the best possible shot at catching some sunlight. It's pure function driving the beautiful form.
And it all comes down to this one specific number, 137.5 degrees. They call it the golden angle. It is the perfect ideal angle for new growth to make sure leaves don't shade each other out, which maximizes sunlight. And what's just unbelievable is that this angle is derived directly from the Fibonacci sequence. It's nature's perfect mathematical solution for staying alive.
And that just leads us to this profound idea. What our eyes see as beautiful and harmonious and elegant is actually just the visual result of a system working at its absolute peak efficiency. The beauty isn't some extra thing tacked on at the end. It's the signature of a job done perfectly.
Which brings us to our next clue, and it's deeply connected to the first one. This signature of perfect efficiency is a specific number known as the golden ratio, and you'll often see it written as the Greek letter phi. And there it is, approximately 1.618. This number pops up in art, architecture, and all over the natural world. There's a reason people have called it the divine proportion.
And here's the connection. This is the kicker. If you take any two consecutive numbers in that Fibonacci sequence, like say 8 and 13 or 21 and 34, and you divide the bigger one by the smaller one, your answer gets closer and closer and closer to 1.618 to phi. That simple growth algorithm and this universal aesthetic constant, they're two sides of the very same coin.
Okay, now this is where things get truly mind-bending. This isn't just about plants. The very same mathematical principle that helps a flower survive is also a huge factor in what we, as humans, find beautiful. Study after study shows that faces and bodies with proportions that line up with the golden ratio are consistently rated as more attractive, and this is true across different cultures all over the world. So, why is that? Well, there are a couple of big ideas here. First, from an evolutionary point of view, symmetry and these specific proportions are really reliable signals of good health and strong genes. And second, from a neurological perspective, our brains literally find patterns based on phi easier to process. And that ease of processing, it registers in our brain as a feeling of pleasure. We call it beauty. So far, we've seen this pattern in plants and in people. But what happens when we just change the scale? Well, it turns out this principle of efficient, self-similar growth, where things get bigger while keeping their basic shape, shows up at every single level of the universe.
We see it all over the animal kingdom. The shell of a nautilus, for instance, grows in a perfect logarithmic spiral. That means it gets larger, but its shape never, ever changes. It's the same elegant curve you see in the curl of a chameleon's tail.
And then we zoom out, like way, way out. The same mathematical principle that shapes a tiny seashell here on Earth also describes the majestic swirling arms of a spiral galaxy that's millions of light years across. The scale is just, it's almost impossible to comprehend, but the geometry underneath it all is the same.
Now, it's really important to understand this, though. Nature isn't just stamping the number 1.618 everywhere like a rubber stamp. The true universal law here is the principle behind it: efficient, self-similar growth. And this principle adapts, which is why a shell and a galaxy might have slightly different angles, but they both follow that same fundamental pattern of growth.
And all of this brings us to one final thought. If the universe's greatest masterpieces are really just the most efficient solutions to a problem, what does that mean for us, for the things we build? Maybe the best art, the most elegant designs, and the systems that truly last will be the ones that find that same perfect harmony between pure function and beautiful form.